In this screencast, my goal is to sort of help you understand how the experiment is actually going to be done for the enthalpy of vaporization and entropy of vaporization experiment. Here's our equation of the day, and as you've already read about, the vapor pressure of water is related to the temperature of water by this equation. Now again, entropy of vaporization is a constant, R is a constant, enthalpy of vaporization a constant, R is a constant. And so if we draw a graph with 1 over the absolute temperature versus the ln of P, we should get a straight line whose slope is numerically equal to the negative delta H of vaporization divided by R, and whose y-intercept is numerically equal to the entropy of vaporization divided by R. So the math to get us this data is going to be kind of a pain, and we'll talk about that in the actual lab. I want to spend this screencast talking about the actual experiment. The way I'm going to do that is kind of sort of step through some experimental pictures, if you will. So here's our experimental setup. Let me sort of talk about all the pieces that are here. In this flask, I have a sealed flask that has a septum sealed, just like we've done in previous experiments. In this flask is mostly air and a small amount of water, maybe 2 milliliters of distilled water. And we're taking that whole flask, that sealed flask, and put it into a hot water bath. And as you can see, the hot water bath there's a stir bar in here. This is a stir plate. And notice that we have a temperature probe in there, and the current temperature is 70 degrees Celsius. So we've heated up the water with our distilled water inside. Connected through the septum, you see that we have 2 different needles. We have one needle connected to our pressure sensor that measures the total pressure, which at this point is 0.9802 atmospheres, because it's reading it. And then we also have this other needle that's sort of stuck in there. The way we're actually going to do this experiment is we are going to put our distilled water into our flask, have it slowly heat up to 70 degrees. Now, the distilled water, as it's being heated up to 70 degrees, is going to be evaporating. If we have our system sealed, then what's going to happen is this air pressure is going to be much greater than 1 atmosphere, and the whole thing is going to start to leak. So what we're going to do is basically heat the water up to 70 degrees Celsius, get all of the distilled water that's going to evaporate at a 70 degrees Celsius to it, and then we're going to let the whole system cool down. So we don't get the system to explode. That's why we sort of have this needle valve, or this needle, stuck in there to sort of let it equilibrate. So we set up our system, we heat up our water. Those are nice flames. Those are pretending to be flames. We heat up our water till everything gets nice and stable. We want to get it, we might shut off the heater at about 65 degrees, and this temperature will still get up. So somewhere around 70 degrees is where we want to sort of start our experiment. So once we get to 70 degrees, what we're basically going to do is we want to start our experiment when all of the water that's going to evaporate has evaporated. Essentially, we've reached the vapor pressure of water at 70 degrees Celsius. So the way we sort of test that is by removing our little needle for a little bit and keeping an eye on the pressure. And if the pressure is sort of stable, that means that all the water that is going to evaporate has evaporated. If this pressure keeps increasing, that means there's still some water evaporating and we haven't reached the vapor pressure. So if we remove that needle and the pressure doesn't change, then we know that our experiment is ready to go. So then what we do is we remove, notice there's no sort of pressure relief needle. The only needle that's stuck in there is still is our pressure sensor, which is measuring our total pressure. And we're going to hit the collect on our computer to start taking the data. And as you can see in this example, our temperature that we sort of started at was 70 degrees. Our system was set up to measure the pressure and the temperature every second. And we kept on taking data, in this case, until it got down to about 66 degrees. We're shooting for about a 5 degree Celsius change in temperature. So if our system doesn't get stable until, if the temperature reads, for example, 69, when we actually start taking our data, then we take it down to 64. So we're shooting for a delta T on the order of 5 degrees Celsius. And in this example experiment, as you can see, it took about 400 seconds, so that's 5 or 6 minutes. And again, remember, our temperature drops because after we've sort of gotten up to that 70 degrees, we sort of shut off the hot plate. It's still stirring. We still have our stir bar spinning the water in here to keep it all equilibrated, but the beaker is slowly cooling off just by sort of the ambient air sort of cooling it down, so we're not going to have to chill it with ice or anything. So now we have our data that we've collected between 70 degrees and 65 degrees. And we have our pressure data and we have our temperature data, which the temperature, we can convert that and do our thing to get it into our reciprocal temperature for the x-axis of our graph. The pressure, however, we have a little bit of a problem because this pressure measures the total pressure of all the gas in the system, which is equal to the pressure of the air plus the pressure coming from the water vapor. So what we're going to have to do is we are going to have to somehow figure out what is the contribution at each temperature coming from the pressure of the air that was in that flask, because it wasn't a vacuum in there, there was some air in there. The way we're going to do that is we are going to make it such that we're going to take this system, our system with our container in it, and take it to a point where the pressure of the water of the gas is effectively 0. And the way we're going to do that is we're going to chill the entire thing. So if we look at our last picture here, so we still have the same sealed system. We have the same sealed system, but now notice that we've changed out the water. We actually carefully disassembled the system, threw out the warm water that was in there, put a bunch of water, and there's a bunch of ice cubes in there. I know it's kind of hard to see, but there are ice cubes in there. And notice that now our temperature is down to 0.2 degrees Celsius, about as cold as we can get. And so now what we have, we still have our pressure sensor. We never disconnected anything. So now our pressure that we read here, which again is the total pressure, we are going to assume is equal to only the pressure of the air that was in that flask while we were doing that experiment. We are assuming that there is no pressure coming from the water gas at this temperature. And we're going to need that to do our calculations, which again I will explain when we are in lab. But there is the experiment.